Greetings, class. I'm going to cover section 6, radical expressions, section 5. I will cover as necessary and skip as necessary. I'm not going to cover sections 6 and section 7. I will expect you to read over those yourself. It's just dealing with roots and square roots and cubed roots and how to simplify them. So, if we need to go back to it, then that's what we'll do. But I'm going to just focus on rational expressions. That's going to be important for the rest of this quarter. So let's take a look at 8x squared divided by 4x cubed. We're going to simplify them. All right, so again, let's take a look at here. 8 divided by 4 is 2, and then x squared over 3. So let's bring this over here. X squared over, sorry, not 3, x cubed. X cubed. And so if you remember from one of the previous review sections, this is just x to the 2 minus 3. This becomes x to the minus 1, which becomes 1 over x. And so we're going to bring that x down here, and that is your answer for number 1. Okay, and you can see that as the case here. Let's take a look at B. So it's easy. This is monomial over monomial and part A. In part B, this is a trinomial, right? 1, 2, 3, 1, 2, 3. Now you cannot just do, oh, let's simplify this, 2 divided by x squared. You can't do that. Okay, you have to, because it's all considered one term, and so you actually have to factor both the top and the bottom. And so let's do that. Let's factor the top. What are some factors of 2 and 3 that will multiply, add and give us -5. So 2 and 3. We can try a few things. We know that this is 2, and this will be x, right? Sorry, x. Okay, and some factors of 3, we want a -5. And so why don't we do, +1 and -3. And so this becomes 2x squared plus x minus 6x minus 3. And so this gives us this term right here, because plus x minus 6x gives us minus 5x. So that's what we have for the top. And for the bottom, let's take a look at x, right? And x. So factors of -3 that add and give you +2. And so again, you would do the factors again, right? You can do them down here. This is -3, so it has to be -3 and 1 and 3 and -1. But only this one adds to gives us -2. Okay. Ooh, what is this? X. Okay, and so we're going to it's written down here, but notice these are the same. And so here you're left with 2x plus 1 over x plus 1. Oh, they wrote it for us, so let's not make that more complicated than it needs to be. All right, I'm going to skip this one right here, but just to notice, this is a difference of 2 squares. So you have x plus 4 and x minus 4, and these two cancel. And so you're just left with this. All right, simplify and multiply and simplify. So multiplying fractions, you want to do your best to reduce. So 7 goes into itself once and into 14 twice. 5 goes into itself once and into 10 twice. And so 1 times 1 is 1, and 2 times 2 is 4. Okay, and that is what our answer is here. So for this one, it gets a little bit complicated, right? So 3 goes into itself once, 3 goes into 9 3 times, 4 goes into itself once and goes into 8 twice, and 2 goes into itself once, it goes into itself once, and so notice you have 1 times 1 times 1 over 1 times 3 times 1, which is just 1/3. Okay, so let's multiply rational expressions. And so there's a few things that we can do. We can reduce this here, 3 and 3, and that looks like that's about it. So you're going to have x minus 3 all over 2x squared. We can see that that's the correct answer. In the next problem, you can reduce x minus 2. You're left with x plus 3 over x. Okay. Okay, we're going to dividing two rational expressions. And so let's take a look at A here. And notice that this first term is the same, but here we're actually multiplying. In invert, we're actually multiplying by the reciprocal. Okay, and so let's try to reduce here. 2x can go into itself once, and it can go into 4x twice. And so we're going to reduce, right? And so now we just have 3 times 2, which is 6, and 3 minus x, which is this right here. Okay. This is another technique if you wanted to have the x right here not be negative. You're going to multiply everything by -1 over -1. And this is essentially saying 1, but it gives you a slightly different answer. Let's take a look at B now. So again, we're going to invert and multiply, as it says here. But if you notice something, you're going to factor this term and you're going to factor this term. This is a difference of squares, so it is just x plus 2 over x minus 2. All right, and then this one is going to be x factors of 3, x minus 3, and x plus 1. And so if you rewrite all of that out, we can start kind of getting rid of stuff. And so this kind of goes away. X minus 3 over x minus 3, that goes away. And so we're just left with x plus 1 over x plus 2. And that is its most simplified version. All right, let's find the least common multiple for each pair of expressions. And so what does that mean? You want to factor each monomial completely, right? So notice we found the factors of 8x squared and 12x, and we're finding all of them, right? So the factors here are 2 times 2 times 2, so 2 times 2 times 2, right? And, times x times x. And same thing for here. This is 2 squared times 3 times x. And so what do? So the least common factor, so notice you find the highest version of each factor and you multiply it together. So here we're doing 2 cubed and x squared and 3. Okay, and you take them all and you multiply them together. For the next term, notice you're going to take this part right here and factor it completely. And then you're going to take this term and factor it completely. And so notice you have here and here, and they're factored, right? And so we're going to take one of each term. Notice this is twice right here. So this gets a term, and x plus 7 gets a term, and x minus 7 gets a term. All right, finding the least common denominator. This is actually going to be pretty important. So notice we're going to find a common denominator for these two fractions. So if you remember, we found using the least common multiple, correct? And so x plus 1, x plus 7, x minus 7. And so you remember from the previous problem, these are still the same. And you're going to do the same thing. You're just going to multiply all the common multiples that they have and multiply them together. Teaching, again, more fractions. So let's add these fractions. And the reason why we're doing fractions first and then going into fractional polynomials is the principle is the same. So we're going to find a common denominator here. Common denominator, so 7 over 8, and let's multiply both by 3, plus 2/3, and we're going to multiply both the top and bottom by 8. And that leaves us with 21 over 24 plus 16 over 24. And that gives us 37 over 24, which is what they did down here. So all I did was I took the denominator of 1 and I multiplied it to the other side of the fraction, and I took the denominator of the other and I multiplied it to the second portion of the fraction. So you might think because the numerators are the same that maybe we don't have to do any common denominator work, but it's always the denominators that need to be the same. So a common number between both of them is 18, right? 18, 2 and 9, and then 3 and 6, right? And so 5 times 2, or 9 times 2, minus 5 times 9 over 6. Oh, I'm sorry. I'm confused. 5 times 3 over 6 times 3. And that gives us 10 over 18 minus 15 over 18. And that leaves us with negative 5 over 18. And they have the same. Okay, so let's try to do some adding rational expressions now that we've looked at some basic fractions. Notice the denominators are the same, so you can literally just add them as is. So 2x plus 1 minus 2x all over x minus 4. So notice I'm not multiplying, I just leave the denominators the same. So 2x minus 2x, so I'm left with 1 over x minus 4. Now notice these are not the same. Okay, but if you remember, we can multiply by the difference of squares, and it'll give us the same denominator. So I'm going to write this out over here. X minus 4 times x plus 4 plus x times x minus 4 all over x minus 4. Sorry, x plus 4, x minus 4. And so now our denominator is the same, right? that's what they have here. And notice here, you can multiply this out, but it's simplified as 3x plus 2 plus x squared minus 4. Okay, so combine all of those terms together. We can do this, and that leaves us with x squared minus x plus 12 all over x plus 4 times x minus 4, right? And we're going to kind of skip through here. It's the same idea. You want to find a common denominator. That's the key thing here. You can go through, and what I suggest at this point is take a look at these problems, try to solve them, and see if your answer is the same. Okay, see if you can get the same answer. Here, clear the fractions from the equation and solve. What does that mean? You're really just, again, finding a common denominator. And so you're really going to multiply everything by this, right? Looks a little complicated, but they were able to do that. And then it also allows them to solve this problem. And this looks a little bit complicated here, like a lot of work. But the reality is things just start to go away. So, you know, this cancels with this, and this adds up to this, and then you're left with here. And so you can solve for x actually, and, you know, x equaling 4/3. All right, so this is going to be it for this section. I'm going to give you a few problems in the classwork.